Hi everyone, my name is Fraser Kane and I am the publisher of Universe Today, and this is your weekly space hangout for May 17th, 2012. This week we're going to be talking about audacious plans to build a real enterprise, the upcoming annular solar eclipse, more evidence that the Earth may or may not be a sentient living creature called Gaia, and fuel for black holes, and then whatever it is that is going to talk about Hubble and the transit of Venus. So on deck, we've got all of our space friends. So we've got Amy Shira Teitel from Vintage Space. We've got Jason Major from Lights in the Dark and some Universe Today. We've got Nancy Atkinson, of course, senior editor at Universe Today. We've got the newly doctored Nicole Gugliucci, and now from CosmoQuest. And I think we should kind of announce that as well, which is that Nicole has moved. You moved to Edwardsville. And
I moved to Edwardsville last weekend, and I'm in New Mexico now for a conference.
For conference, that's what Pamela does.
Life with Pamela Gay.
Exactly. But Nicole is now full time helping out with CosmoQuest. So that is really exciting. And I know.
think that's always really good to see happening. I mean, yeah, you're right. Thinking out of the box, terrible turn of phrase, but this is what people have to be doing. They have to be taking their imaginations, and what's more familiar to people than Star Trek and Star Wars and things like that, things that everybody knows about, and this guy's saying, yeah, well, you know what, this is an imaginary future. Why can't we make it our real future? And that's really cool. So I think that's really the key part of this here. Whether or not this thing actually launches or gets built is probably something else entirely.
Yeah, and I think the nerve he really touched on, and it's something that we see again and again, is the demand and interest in better human spaceflight, a better human spaceflight program. That what the government and NASA and things like that, the path that we're on, doesn't match, I think, what people would be willing to fund and willing to participate in. That there's some kind of disconnect, and that there needs to be some other kind of funding model, some other way that these kinds of ideas get done, be it through SpaceX, through the commercial spaceflight, or maybe it's going to be something through Kickstarter, where some ragtag group of people say, well, we're going to build a spaceship and it's going to cost $100 million, and they're going to raise it with Kickstarter, and they're going to do it. So I think that there is this demand, there's this pent-up demand out there for the exploration of space to continue in a more ambitious way. And I think that's what he was doing, and that's what I think other people coming on right now can touch on, that same sort of catch that same lightning in the bottle. So that's the big lesson that I'm taking from this is we need to launch a spaceship. So
let me run an addendum there just really quickly. Like I said, I like this guy's thinking and everything. I don't think it's realistic. Planetary Resources, on the other hand, are talking about something that is essentially very ambitious, going to asteroids and mining them, and they have actually laid out their plan step by step with the funding. They've got their backers. They've got the billionaires who are actually funding them. They're going to do it, and I think that can work. So I don't want to come across as this gigantic wet blanket on this. I like this idea, but I think that if you want to be realistic about it, there are ways of being realistic about it and exciting the imagination, as opposed to just throwing everything out there and seeing what sticks.
Yeah. All right, why don't we move on? So Phil, you were going to announce the upcoming annular solar eclipse, which is going to be on the 20th.
Yeah, let me get my webpage up here because I want to make sure I get the numbers right. Yeah, there's going to be an annular eclipse. It's Sunday, it's sort of evening in Universal Time. The timing is 2056 Universal Time. That's when it starts. That's at very roughly 5 o'clock in the afternoon on the East Coast. This is favoring the west coast of the United States. The farther west you are, the better. I live in Boulder, Colorado. The sun is going to set while it's eclipsed. If you're in Japan, that's good. But looking at the map here, I put a map up on my website. Albuquerque, Gallup, Reno, and Redding, California. These are sort of your bigger towns that are right in the center of the eclipse path, and that's good. What's going to happen here? I have, of course, models. Here's the sun. Right? Let me get my screen up here so I can see what I'm doing. Here's the sun. Here's the moon. Right? Ping pong ball, tether ball, not to scale. But let's see if I can do this right. Oh, I have to hold the volleyball way back. Oh, my gosh. Right? In the sky, the moon and the sun are about the same size. Let's see here. There we go. Something like this. Boy,
you need longer arms, Phil.
This is super hard to do. Here we go. Because I'm also looking at the screen backwards, and there's a delay. So when the moon passes in front of the sun, you get an eclipse. And they're about the same size. So a lot of the time, and I got to get my head out of the way. This must be great TV, right? So a lot of the time, when the moon and the sun are at the same time, shut up, Nicole. Oh, now you have a PhD. Now you can make fun of me. Okay.
Right.
So a lot of the time, the moon and the sun are the same size in the sky, so the moon completely blocks the sun. But the moon orbits the Earth in an ellipse, so sometimes it's smaller and sometimes it's bigger. Now, we just had a full moon when the moon was closest to the Earth, and that was called a supermoon, and you can find my opinions on that online. However, 2 weeks later, the moon is at the other side of its orbit, and it's farthest away from the Earth, and that so happens that it's happening when it's going to line up with the sun. So the moon is actually a little bit smaller than the sun. Tilt my head, move the moon, and you can see just a little bit of the sun around the moon there. Not the best way to do it.
Phil is playing the role of Venus on June 5th.
My giant, hot, carbon dioxide, sulfuric acid raining head. The point here is that the moon is going to be smaller than it usually looks, so it's not going to completely block the sun. There's going to be a ring of sun around the moon. This is called an annular eclipse. Annulus means ring. It's also called a ring of fire, which I like, actually. That's cool, because there's this ring of light around the moon. And if you're in a very narrow path across the United States and just south of the Aleutian Islands and over in Japan, you will see this effect. If you're outside of this path, you'll just get a regular old partial eclipse. That's what I'm going to see here in Boulder. I'm actually pretty excited because the sun sets over the mountains where I am. So the sun is going to set in eclipse. And I think we're going to get some gorgeous photography of that. You can go online. There are a ton of places to find maps. I know Universe Today covered this. I literally just posted about this a few minutes ago. If you look up May 20th eclipse, you'll find a ton of information to see if it's visible from where you are and what you'll see.
Yeah, I live on Vancouver Island, so I'm going to be north of the path, but from what I can tell, I'm going to see about an 80% eclipse. So pretty much if you're on the western side of Canada and the United States, it's worth attempting to see this. That for big chunks of the continent, it's going to get dark and weird for a little while the eclipse is happening. Because I remember one happening back in like the 1980s, and even though it was only a partial eclipse and less of a partial eclipse than what I'll be getting this time around, it's still going to be pretty. It's still going to be pretty dark. It was dark then, and it's going to be even darker this time. So I think it's a pretty weird effect. I'm looking forward to it. I considered throwing the kids in the car and heading south to try and get to Redding, but I think if it was a total eclipse, I would make that trip. But if an annular eclipse, I don't know if I'd make that trip. So
we kind of have the same dilemma since we're just north of Albuquerque for the conference. The idea was to stay a couple days, but I think my collaborators haven't seen home in a while and want to see home, and I haven't unpacked. So we are going to miss it.
Yeah. So, but anyway, but if you're anywhere on the West Coast, try to just see it. And there's great ways that you can see it. Look up. You can do projections. You can use binoculars. Don't look at the sun with the binoculars. You will burn your eyes. But there's lots of ways. So safe. Yeah. Google for safe eclipse viewing, and you should get lots of suggestions on how to see it.
I'm glad you added that, Fraser, because you know what? I didn't put that in my blog post, so I'll add that. But yeah, don't just slap on sunglasses. Nicole is showing the latest fashionable eclipse glasses.
Yes, I just got these at the conference from some NASA people for the transit of Venus to actually. But yeah,
these are great because these block the right amount of light. They block ultraviolet. You don't want to use sunglasses because what happens then is that it makes everything dark, but then your pupils dilate, and that lets in more of the dangerous light if your sunglasses aren't rated correctly for the ultraviolet light. So don't just slap on glasses. Get the right protective glasses.
Like these, I cannot see through at all unless you're actually looking at the sun.
And you can order like 5 packs of those from Amazon.com for like $5. They're not expensive, and
I think it's probably too late though.
It probably is for the eclipse, but you'll still want them for the transit. So the transit is on June 6th of Venus, so which is going to be even a more rare and momentous event. So get yourself a pair of eclipse glasses. Just have them on hand because there are partial solar eclipses and interesting things to see on the sun all the time. I mean, there's huge sunspots on the sun right now that I think you'd be able to resolve if you had a good pair of eclipse glasses on. So
that big sunspot region is right on the western limb of the sun, though. It's about to.
Oh, well, it was there just a couple of days ago.
It's about to rotate around on the far side.
Yeah. All right, why don't we move on?
I've got a question for Phil regarding the eclipse. Will this be useful for any scientific observation, or is it basically just hey everybody look?
I think this is just cool. An annular eclipse. I mean, total solar eclipses are good because you can see the corona. You can see the sort of very wispy outer atmosphere of the sun, but we can see that from space all the time now. There are some eclipse effects. There's temperature changes and different things like that can be measured during a total eclipse. But with this one, I have a feeling with only at most 94% of the sun being blocked, I don't think those effects are going to be as strong. But again, Google it. So if anybody's curious, I don't think so, but I might be wrong. So check it out.
So I want to move on to Jason. Jason, you've got a story about Gaia, the Gaia theory that the Earth is one great big connected superorganism and is completely sentient and
knows what you're saying right now.
It knows what I'm saying right now. That's right. Yeah, and it was like in Avatar, right? When the planet allied the alien creatures to
you just
defend the planet.
You plug your hair into the tree, and then the tree knows and can tell you what to do.
So is that what's been discovered?
Yes, no, not at all. There's no magic trees. I had never heard of this. Well, I shouldn't say never heard of it. I'd come across it a few times, but I never really paid it much attention. But I guess it's been around. Now the hypothesis has been around since the 70s, and I think it was proposed by James Lovelock and Lynn Margulies. And what the idea is that Earth isn't just a stage, a planet that just happens to be in the right spot from the sun. So that Earth can support life. It's not just a stage. Actually, life is building the stage. It's actively creating the environment for itself, and in doing so, the entire planet is kind of like a big cell, I guess. That it's a strange. I mean, it's a strange hypothesis because it can get kind of hippie. I mean, because the idea of it is it sounds kind of mystical. They gave it a name that reflects back to Greek mythology, but there's actually a lot of science involved in there. A lot of science, a lot of chemistry, a lot of biology that supports tenets of the hypothesis. Now, I say hypothesis, I say theory. It's kind of I've seen both of it. I've seen the Gaia hypothesis, the Gaia theory. They both reflect the same idea. Earth is a single living organism. Sentient, I'm not quite sure where to put that descriptive, but the idea that the whole thing, everything's connected, and Earth makes its own environment for life. Well, one of the ideas behind this is that marine organisms can create compounds. They would emit sulfur compounds. Sulfur is the 9th or 10th most common element in the universe. It's very important to life. It's also very important for climate regulation. Well, researchers at the University of Maryland have found a way to identify some of these compounds, sulfuric compounds, that are emitted by plankton, by phytoplankton, by algae, and can make it through the marine environment and actually get out into the atmosphere and then make it to the land, and of course creating a whole sulfur cycle, getting back into the ocean where they metabolize it and all that. So their research may or may not support or refute the idea that the planet is, has this whole self-regulating system. Whether or not it says that Earth is a sentient being and knows what's going on, and you can plug your hair into it when you're going to pass away, is something else entirely. But the idea is really intriguing, that they're able to track these sulfuric compounds from the ocean to the atmosphere to the land, and basically see if they're the same thing. They can kind of track them all the way back. So it's just identifying another natural cycle wherein life can create a self-supporting habitat for itself. So it lends itself back to the Gaia hypothesis or the Gaia theory, however you want to see it. But that was the news that came out this week from the University of Maryland.
So is it kind of like that the Earth is routing these sulfur chemicals where they need to go on the planet?
It's kind of that. It's the whole process of life actively creating its own stage, its own environment. It's not just that our planet happens to be in the right place for life. It's that life is creating itself. It's maintaining its own climate, and not just the things that it needs to metabolize, but it's establishing a climate that it needs. Because what they can do is start to see how the climate changes in response to what's being put out by these marine organisms. So, it's just another part of the whole interconnectedness of things. Now, again, does it mean that Earth is one huge living organism? I don't know. Doesn't mean that it isn't. That I don't know either. But it's just going to be one more way to track whether or not these things are all connected. And you know, in the very least, they'll be able to find, they'll be able to track a very important compound, these sulfuric compounds, through the climate and find out, you know, how they're related to very important pieces of the environment, which is marine organisms, these phytoplankton. I mean, they're doing a lot of stuff as far as regulating the atmosphere.
Right. Right, but I can see that it's almost as if there is a balance point, and the life on Earth possibly is working together to bring the climate, or bring these sort of various parts, the temperature, the atmospheric consistency, the amount of usable sulfur, etc., back into this happy place that then
basically, yeah,
maximizes the amount of life that can happen on Earth.
Exactly, where it's self-regulating. You know, if it's too hot in your house, you know, you can turn down the thermostat, and that's the whole idea that you know, Earth can support itself. Earth can support its own life. You know, does that mean it's an organism? Well, you know, it doesn't reproduce, or are we part of the whole process? And if we colonize other worlds, is that Earth reproducing? So there's a lot of questions involved with the whole hypothesis, but it's an interesting concept anyway.
All right. Well, last but not least, we're going to talk to Amy about the plans to use Hubble to stare at the sun by the moon.
Yeah, so like us, Hubble can't look directly at the sun, or else it'll fry its you know, would-be eyes. So the transit of Venus is coming up on June the 5th or 6th, depending on where you are in the world. So what that means, and I'm not going to try to do props or anything, Venus is much smaller than the moon in our sky, and it's going to cross in front of the disk of the sun, and we can see it as a tiny little black dot moving its way across. So Hubble has an awesome vantage point. I would love to see this from space, but it can't look at the sun, so it's going to watch the light of the transit bouncing back off the moon, which I think is a really cool way to do it. So the light from the sun is going to be passing through the atmosphere of Venus, and Hubble is going to use to measure the atmosphere coming back off the moon to determine what its atmosphere is made of. So we know what the atmosphere of Venus is, but what they're using this data from Hubble to do is calibrate how it's going to analyze the light coming in from exoplanets, which is kind of a really, really cool application of this really rare scientific event. Yeah, so if Hubble can accurately determine what the atmosphere of Venus is based on this method of bouncing the light back off the moon, then it can do the same thing and reasonably take really good measurements of what exoplanets are made of in terms of atmosphere. So that's going to happen.
And so this is more, like as you said, this isn't like because they know what the atmosphere of Venus is. It's not like they're trying to figure it out, or they're not going to. The point is, this is a calibration.
This is a calibration.
So let's see if we can figure out what the atmosphere of a exoplanet is made of, just purely through the changes in the light that comes from it.
Yeah, and I think what they're trying to do is see if bouncing it off the moon is a way to do it. If Hubble can't look at another star, if it can do the same thing, if it can look at the light that's bouncing off the moon to try to determine what the atmosphere is. So that would be a really neat way to look for exoplanets, of reflections of the planet from its own light.
Well, and we've mentioned this in the Hangout and definitely in Astronomy Cast, we talk about this a lot, that if you can look at the atmosphere of an extrasolar planet, that tells you a lot. And in fact, if you know the atmosphere of the planet and you can see like free oxygen in the atmosphere, then that's almost a perfect indication that there's going to be life on that planet. There's lots of chemicals that just can't exist naturally in nature. They have to have some kind of process that's going on that's actually generating it. And so, in fact, being able to detect the atmospheres of these distant planets is the holy grail of
it's
planetary
a huge step in the
search,
finding another Earth and the whole, you know, search for life and following water. Because if you can see water vapor, then there's water, and then, you know, it's worth more study. And maybe we'll take that giant Starship Enterprise over there and check it out. I don't know.
Fire up those ion drive engines. We'll get there and let's see.
Warp on over and
like
see what
happens. Like a million
happens.
years, yeah. Cool. I said last but not least, but what I meant was, last but not least, we've got Nicole talking about fuel for black holes. So Nicole, what was this story? And it's in your field, right? It's all radio.
No, it's not radio. It's
not
optical,
radio.
but it is an interferometer.
Mm.
So the way you measure, one way to measure tiny things on the sky is that you need a larger and larger telescope, but in some cases you combine the power of multiple telescopes together into something called an interferometer. So they did this with the Very Large Telescope interferometer in Chile and looked at a supermassive black hole, the center of a galaxy. I think it's NGC something 3783. There we go, 3783. To try and see what the environment is like around this black hole. So the current hypothesis for, all right, back up a little bit. These things are called active galaxies, or active galactic nuclei, or AGN. So it's basically when matter is falling onto the black hole and it's making it really bright and do all kinds of crazy stuff. There are different kinds of AGN that have been discovered over the decades. Some of them give off radio waves, some of them you can see an X-ray, some of them have a certain type of absorption line, some look different. There's this whole zoo of AGN, of active galaxies. And in the early 90s, there was this popular hypothesis that is still well known today called the
can't wait to see what else they're going to do with it.
Now, Nancy had to leave us. She has a a telecon that she has to call into for space exploration, so she's already gone. I don't know if anyone else needs to jump into that. If anyone has no idea what I'm talking about, that's fine. So anyway, we got a few questions, so why don't we quickly get through those, and we'll free everybody. So if anyone has any questions about any of the stories that we talked about today, or at any point, or any ideas at all ever, just post them into the comments where you're watching this Hangout, and I will scoop them up. So a couple of questions here. So John McKinney wants to know, he said he's surprised that the moon would not be too bright for Hubble, so I guess this is this observation of Venus. Is it, I mean, the moon does reflect a lot of the light from the sun. It's, it's still pretty bright in the sky, but that's not too much for Hubble?
It's not, actually, in everything, all my researching for the articles that I wrote on this, didn't say that it was too bright, and it might have to do with the area of the moon that they've chosen to focus on. It's the Tycho crater, which I was going to pull a picture up of and share, but I didn't have time because it's a little late. So it might have to do with that being a little bit of a grayer and more varied surface. And I don't know if maybe Phil can speak to how Hubble actually works a little bit, but it might be, I mean, the exposure of the transit is actually 7 hours. So they might be doing it at such a sort of taking in light in such small bouts that it's not going to kind of fry its eyes the way looking at the sun would. That's
Uh-oh. We lose her?
Did we lose her?
That's the one thing I'm not totally sure. Oh, hi?
Yeah, you're okay. You're okay.
Okay. So no, the moonlight isn't going to damage it, but I'm not completely sure why now that you bring it up. Go ahead.
I didn't bring it up.
I know.
Okay, Phil. You worked on that camera. You invented that camera, right?
What's that?
You invented the camera on the Hubble.
Yes,
I knew you worked on that.
I think they are using the Space Telescope Imaging Spectrograph for this, which is a camera I helped build. I didn't invent it. But in fact, Hubble, there's a series of things you can talk about here. One is that there are different instruments on Hubble. You think of Hubble as like a telephoto lens that you can strap different camera bodies onto. And there are different cameras on board. Some of them are more sensitive than others. But they can take extremely short exposures. So it turns out that Hubble not only can observe the moon, it has several times. I was on a couple of projects where we observed the moon with this camera. The problem isn't the exposure time, because you can take very short exposures and not overexpose the camera. The problem is the moon is moving really quickly, and Hubble can see such fine detail that you're trying to basically take. It's like a picture of a race car zooming by. If you don't take a really super short exposure and aim the telescope exactly right, you're going to miss it. So what they do is they kind of point the telescope where the moon's going to be, wait for the moon to move in, and then take the shot. So they can take pictures of the moon. In fact, Hubble routinely observes the Earth, which is far brighter than the moon. They do that for calibration reasons to make sure that the cameras are behaving properly. Also, what they're doing is they're not taking, as far as I understand it, they're not taking a photograph. They're not taking an image that you can look at. They're taking a spectrum, which breaks up the light by colors. And when you do that, you can actually determine sort of the chemical elements that you're seeing. So as sunlight passes through Venus's atmosphere, those elements like, well, the carbon dioxide, the molecules of that, and other things will absorb certain colors of light. So they're going to look for that in the lunar observations. But to do that, you're taking that light and you're spreading it out at all these colors. That dims it. It's like taking, it's like having rain falling into a bunch of different buckets. I'm trying to think of a way to describe this well. But each pixel of the camera is going to see a lot less light than it normally would, and it's actually by a factor of 1,000. So suddenly an object that might be 100 times too bright to observe, say, might be easily observable by doing it this way. But they can observe the moon anyway. So I'm trying to make this as confusing as possible because I'm thinking of too many things at once. The point is the moon is not too bright. It's been done before. This is an extremely difficult observation. I'll be very curious to see how they do it because they're looking at something that is changing by a tiny, tiny fraction of a %. And while they're observing, the sun is changing its angle on the moon. It's illuminating the moon differently, and they're going to have to take all those effects into account. It's going to be very complex and difficult.
They're going to
And
be
I'll add
taking multiple shots, right?
And I'll add that Hubble is orbiting the Earth, and the Earth is blocking its view of the moon periodically.
Because we put the audio into the Astronomy Cast feed, we record the show every week on Thursdays at 10 a.m. Pacific Time, 1 Eastern Time. So if you ever want to watch us live and ask your questions, we'd love to have you watching us. It's on Google+, it's on YouTube, it's on CosmoQuest, so you should have lots of opportunity to be able to watch it. So, so thanks to everybody who joined us. Thanks to everybody who's watching, and we will see all of you next week.
Thanks, Fraser.
Bye, everybody.
Thanks, Fraser.
Bye.
Thanks.